Welcome back to my channel. Today we're going to do a problem that I got it from my friend last week, and I'm gonna show you what he sent me. This is the post. All right, and I just copied down the question from the post. Well, it's actually said that in the post, what you saw was a birthday cake that was prepared by parents of a high school junior student for his birthday, and instead of saying simply "Happy Birthday" on the birthday cake, what his parents decide to give him was a problem that was from the entrance exam in 1995 Kyoto University. And this problem is, of course, written in Japanese. And here is the actual problem. And I'm going to translate it into English so that everyone can read. Here you go. Okay, so here is the English translation that I made, and also asked my friend to help me to check. And here it is. Let n to be any natural numbers. Now keep in mind, when we say natural number here, we do not include 0. And define functions f of n and g of n by f of n is the remainder of n divided by 7. So later on we'll use a better notation to describe what f of n is. And g of n is equal to 3 times f of the quantity from k equals 1 to n of k to n power. Okay, now what's the question I'm asking? It's asking to prove that for all n natural numbers, f of n to the 7th power is equal to f of n. Second problem, we have to choose any natural number n, and then the score of problem 2 will be the value of g of n, this function here, for n that you choose. In other words, the final results of problem 2 that you get is based on what number n you choose. And we would like to see how we can maximize the score in problem 2, and also, of course, we need to show how to prove problem 1. So let's get into the proof and the solutions. Great. So I just decided to rewrite the function f of n, which is equal to x, that's congruent to n mod 7 for, of course, x is between 0 to 7, not including 7. And once again, that's how we use modular arithmetic to define the remainder after divided by some number. Okay, and if you don't like this symbol right here, modulo 7, we can also rewrite the function in the following. We can just set f of n equals x, not x, excuse me, we're using n here, n minus n divided by 7, but we're now going to take the flow function of it, and then we're going to multiply the new value by 7. So here, when we take the flow function, we are now thinking of the quotient parts of n over 7, or n divided by 7, so that if we have any remainders, we're gonna ignore it at the moment, or if there's no remainder, this is just an integer without the flow function. Then if we multiply back by 7, we'll actually get the closest multiple of 7 to n that's not bigger than or equal to that's not bigger than n. Okay, so that now if we subtract from n, we'll actually get the remainder part. So this is another way to write f of n. Anyway, let's jump to the first part. So we want to prove that, show that f of n to the 7th power is equal to f of n for all n natural numbers. Okay, so if we consider of this part here, if we use the modular arithmetic definition, we're saying that the left-hand side of here is now equal to n to the 7th power in mod 7, of course. And remember, we need to reduce n to 7 to something like this. But at this moment, it doesn't matter because we're taking the modulus 7. So why do we want to do this? Well, again, we can now use the Fermat's-Little theorem. If you don't know what it is or don't remember, go back and check my old videos. I've explained it a few times already. So through that theorem, we see that 7 is a prime number. So by the theorem, we get any natural number n raised to the 7th power must be congruent to n itself in mod 7 or modulus 7, which is same as f of n, the right hand side. If we look at our definition here. Therefore, we just simply proved that for any natural numbers n, f of n to the 7th power is equal to f to the n itself. Good. So we just finished the proof in 3 lines. Okay, so now we're in problem 2. And again, we're trying to maximize our score in problem 2 because it says the score that we will get in this problem is based on the natural number n that we choose, but not directly the natural number n. We will get the score that's equal to the value of g of n for the n that we choose. So keep in mind, g of n is actually a function that's based on f as well. So if we look back the definition of f of n, we see that there are only 7 different values that we can get for f of n, which is 0, 1, 2, 3, 4, 5, and 6. Keep in mind, 7 is not a valid answer for f of n because when we talk about the remainder, it has to be strictly less than the number that we're dividing by. And here, when we're taking an integer to divide by 7 and find out the remainder part, we will see that the remainder is also an integer. So we only have finitely many options. In other words, in order to maximize our score in problem 2, it is equivalent to find out some n value such that we can maximize f of this quantity here, which gives us the maximum value of g of n. So, of course, the best way is hopefully we will get f of the quantity k equals 1 to n for k to the n power to be equal to 6 somehow, so that we'll be able to get the maximum score. Are we be able to do that? Or is there any n that can satisfy this? Well, in fact, yes. Because, again, we're going to use the Fermat's-Little theorem one more time. And this time, instead of saying that n to the p power is congruent to n for mod p, we're going to use the alternative version, which is for n that is not divisible by p. We also know that n to the p minus 1, how do you say it? P to the first power, p to 1 power, I call it p to 1 power. N to the p minus 1 power is congruent to 1 mod p. What does that do to this? Well, if we want to maximize this, let's try to set n to be equal to 6. So if we let n equals 6, then here this summation will be equal to k starting from 1 up to 6 for k to the 6th power. Then we will have 6 different terms: 1 to the 6th power, plus 2 to the 6th power, plus 3 to the 6th power, plus 4 to the 6th power, plus 5 to the 6th power, plus 6 to the 6th power. Good. So don't forget, this is everything inside of the function f. Now let's try to take the function like this. So we're going to put it in the function f. We will get the following: f of 1 to the 6th power plus all the way to the 6 to the 6th power. I know this is a big number, but don't worry. We just have the Fermat's little theorem. We can just use it to help us get the answer. Again, that's because of how we define the function f of f itself, f of n. So, in fact, it means that it doesn't matter what we have inside of the input. We always need to reduce it down to something between 0 to 6 by dividing by 7. So this here would then be congruent to the sum of these values, where by the Fermat's little theorem, if we divide it by 7 or raise it to mod 7, we will actually get each one be 1. Again, because 1, 2, 3, 4, 5, and 6, they are all not divisible by 7. So if we raise it to the 6th power, which is 7 minus 1 power, each one will actually be congruent to 1 by the little theorem. Therefore, we just have 6 copies of 1 adding together, which gives us 6. And again, this is also how we define the function f of n, because we want the smallest positive value or 0 to be our output. Good. So we just found that when n equals 6, this part f of the big sum will be equal to 6 as well. This is what we want to find. So, of course, now we can see that if we choose n equals 6, we get the following, so that g of 6 would then be equal to 3 times f of this quantity here, which is equal to 3 times 6 equals to 18. And this is how we can maximize our score in this problem. And is there any other values that we can choose so that we also can maximize our score? Could be. I've not checked it yet, but it doesn't really matter if we choose something bigger or smaller, because our score does not directly base on the value we choose. We have to do all the calculations, so we can choose the smallest one that we know that can give us the highest score. Okay, and that's it. I think it's very cool. So I hope you all will enjoy this video as well. And yeah, if you like this video, don't forget to like. And if you want to watch more of my other videos, please don't forget to subscribe and then turn on the notification so that you won't miss any of my new videos either. I'll see you guys next time.